Okay, so we need to create 3 subnets, right? Subnet 01, 02, and the name of the subnet will be just subnet 03. What is the number of IP required in first? 509. Okay, so if we go ahead with 2 to the power 10, then it will be 1024. 1024, which is greater than 390, sorry, 509, and 512 is also greater than 509, right? This 1024 and 512 is the total IP we get in a particular CIDR. If we go ahead with CIDR range of 22, then we are getting 1024 IP address. If we go for X equal to 23 CIDR range, then we are getting 512. So, as per our requirement 509, 512, which is nothing but 23, will also suffice the need. But as per AWS rule, first 4 IP address and the last IP address of the subnet is reserved for AWS users. So in that case, we will be getting 512 minus 5, which is 507. And in that case, 507 is less than 509. So our requirement will not be fulfilled. The next option is 1024. We don't have any other option between 512 and 1024. So considering 32 bits and then keeping 10 bits for the variable, we will be having 22 bits which can be freezed, right? So in that case, the first IP address of the subnet, we will start with 157.2.0.0. Okay, leave the last IP address for now. What will be the range of this? 22. So the CIDR, to form the CIDR, what we need? The first IP address and the range. So we have both 157.2.0.0/22. So this is the CIDR of my first. So this is the CIDR of my first subnet. Please write it down. 157.2.0.0/22. Okay. What will be the last IP address of this? Because unless we know the last IP address of first subnet, we will not be able to pick the correct IP address which is free for the next subnet. Right? अभी तक जितना यूज हुआ है उसके नेक्स्ट वाला कौन सा फ्री है जिसको हम फर्स्ट आईपी एड्रेस कंसीडर करेंगे दूसरे सबनेट के लिए, राइट? So in that case we will need to know the last IP address of this range. So how many IP address will be there? There are total 1024 IP address starting from 157.2.0.0. This is the first IP address, and this can go to 157.2.0.255, right? So here this will be same. So 157.2 will be same for every IP in my VPC, and 157.2.0. So in this range we are getting how many? 256. Now next 157.2.0.0. Okay, can we start from this IP address? This has already been consumed, right? So can we start from this IP address? No, because the maximum limit is 255 of any block. So in that case, we will start with 1 and then again from 0. And this will go to 157.2.1.255 maximum. This is the maximum limit it can go, and here also it will get. So this is the range of 1. Okay. Similarly, we can have the range of 2 now and then 3. So this will be just 2. Here it will be 2. Here it will be 3, and here it will be 3. Right? So now how many IP addresses are there? 256 plus 256 plus 256 plus 256. How many? 1024. The total number of required IP address in this range. So now look at the IP address which will be the last IP address of this range. 157.2.3.255 will be the last IP address, isn't it? This will be the last IP address for this subnet. Okay. So now, what is the next requirement of the subnet 2? 312. 312. 312 is the exact number of IP address, usable IP address, which is required for in this subnet. Right? So we have the block of 512 IP address, and lesser than that we have the block of 256. So if we go ahead with, we cannot go ahead with 256. Obviously, we will have to go ahead for 512, and that will suffice the need. So 512 is the suitable range for this requirement. So 512 means what? If I am looking for a block of 512 IP address, then what will be the total number of freezing blocks? Okay, what will be the total number of unfreezed blocks? 9, 9, 9, right? So 32 minus 9 will be the total number of freezing blocks. This will be 23, isn't it? Any doubt? No? So now we'll go ahead with the 23 range. And what will be the first IP address? The very next to this IP address. So 157.2.0.0. This is no. Wait. This will be 4, right? So we have the first IP address. We have the value of x now. Which block will be suitable for the CIDR? Now we can form the CIDR. Okay. 157.2.4.0.23. Okay. What is the next requirement now? 59, right? For the third subnet, what is the requirement for the third subnet? 59. So which block will be suitable for this? 64, less than 64 is 32, obviously not suitable. So 64, okay. So in 64, if we minus 5, then what will be the value? 59. So exactly matching, right? Exactly matching, it means 64 block will be sufficient for me as per this requirement. Okay, so when we go for the 64 block, 64, then what will be the number of freezing bits? 26. 26 is the freezing block. So we got the value of x now 26. Now we need to find out the first IP address. And to find out the first IP address, first we need to find out the last IP address of the last subnet, subnet 2. So again, following this same pattern, the first IP address is 157.2.4.0 and total number of IP address allocated to the second subnet is how much? 512, right? So 512 means there will be two series of 256 and 256. So looking at this, if I just copy this, then I just need to replace this with 4. Sorry, this will be 2 and I just need to replace this with 4. This will be the fourth series with 4 and this will be the series with 5. So the last IP address will be this one. 157.157.2, then 5, then 255. So now the next free IP address is what? 157.2.6.0 and this will go to, okay, so wait. Now first IP address is with us, value of x is with us, so we can have the CIDR ready. Okay, so this will be 26. Now we have the CIDR for my subnets ready. Then, but what will be the last IP address for this one? Starting from 0, starting from 6.0, 6.1, 6.2, 6.3, 6.4, 6.5 till what? 63. So 157.2.6.63. Got it? So now we are ready to go ahead and create the VPC and subnet. Okay. I'm going to my VPC console now. We know that VPC is region specific and in one region you can form maximum 5 VPCs. So there is a process of creating the VPC using Wizard. This Wizard will create not only the VPC but other components also like Internet Gateway. If you want to make the subnets public, it will create the subnets, it will create the route tables. So everything which is required to use one VPC will be created in one go. But we want to create every components individually so that we can learn practically how it is done. So we will not be starting with the start VPC wizard. Instead, we will go to the VPCs, and here you can find that there are two VPCs, right? So we will be creating a fresh VPC, and the name of this VPC will be AWS underscore ISO. The CIDR for this VPC we are already handy with the CIDR. It's 157.2.0.0 slash what 16. Yes. Now go ahead and create the VPC. Our VPC is ready now. Now we need to create the subnets. So we have the requirement of creating the 3 subnets. So let's create first subnet. We'll give the name AWS underscore ISO underscore 01 because this is the first subnet. And from here you can see that this is the default VPC. I will have to select the VPC under which I want to create the subnet. So let's go ahead and select AWS underscore ISO. And the moment I selected the VPC, it is reflecting the CIDR of the VPC. Why? Because it is showing us that the CIDR which you are going to select for the subnet should be the subset of this VPC CIDR and should not overlap with the CIDR of any other subnets of the same VPC. So we don't have any other VPC, any other subnets for now, so there is no worry about conflicting or overlapping of the CIDR. So just we will make sure that the CIDR which we are selecting for the subnet is the subset of the CIDR of VPC. So we have already designed this 157.2.0.0/22, where we are looking for how many IP address? 509. The requirement is 509, but we will be creating a subnet where we will be getting 1024-5. So 1019 IP address will be allocated to this subnet, which will be for use. Now let's create. If you give wrong VPC CIDR here, it will give you the error. If you are not getting any error by clicking outside, it means it is okay. Click on yes and create the subnet. Now the subnet is created here, and the correct VPC is for this subnet, and you can see 1019 is the available IP address. So the first 4 IP address and the last 1 IP address has been reserved by AWS. Okay. Similarly, we will be creating 2 more subnets, AWS_ISO_02, and here select the correct VPC. Now, at the time of creating the subnets, since the subnet is availability zone specific, data center specific, so it is an option to you that you can specify a specific availability zone at the time of creating the subnet. Okay, and if you do not specify any availability zone, then it will randomly give you, or it will create your subnets in any of the availability zones randomly. Okay, but whenever we create subnets, we make sure that subnets are distributed across different availability zones in the region, because it will increase the availability of my application. Okay, let me confirm. So this subnet is in EU West 1B. From here you can see that this is in EU West 1B, and the second subnet I will be creating in 1A, and the third subnet we will be creating in 1C, so that we will have subnet distributed in all areas. Now we need to give the CIDR for this one, so it will be 157.2.4.0/23. This is the CIDR which we designed for the second subnet, right? Correct? Okay. Create. The second subnet will be ready now. We just need to create the last subnet. And from here I will select the 1C availability zone. Now 157.2.6.0/26. Just confirm 157.2.6.0/26. Now create. So we have 3 subnets created. Now we can go ahead and start launching the instances, servers, or any such applications which we want to launch in the VPC, in the subnets. Now there are a few more components which is required along with the VPC and subnet, and those components are responsible for the network build out, where whatever we have designed or whatever we have created so far, this is just a virtual place where my server will reside. Now we need to design the components which will create the communication channel through which instances or the servers or the resources that we are creating inside the VPC will communicate within itself, and it will communicate to the outside resources. So whatever we have created, the VPC and subnet, it is just the virtual space where my resource will reside. But how my resource will communicate internally or to the outside resources of the VPC, this is something we yet need to define. So now whatever components that we are going to discuss, you understand the use case, right? That will be for the network channel or the communication channel. For, yes?
But we already have security groups in EC2. If we place them in VPC, then they are already different, right?
Okay, so security group is just the set of rules which will monitor the traffic coming in or going out of your server. It is not creating any communication channel. Okay, so those who are not from the networking background, to help you understand it in easy language, imagine that this VPC is nothing but an island in sea. You can consider it as a man-made island in the sea, okay, which is surrounded by water. And on that island, you have created some apartments or the buildings where the people will reside. Fine, but there is no proper path or no proper gateway or which through which people will communicate within themselves or to the outside people. So now we have to design the communication channel so that the people residing in the apartments on that island will communicate to the outside people. Okay. So very first thing we will be creating is the internet gateway. Internet gateway is nothing but you can even consider it as a gateway on that island, which will allow the people coming from outside to enter into that island. So it is purely for the people coming from outside through internet. So on VPC, in the VPC, we will be creating one internet gateway, and then we will be attaching the internet gateway to the VPC, so that any any communication request which is coming from internet can communicate to your server. One use case, let's say that you have launched one EC2 instance which is a web server. So you are hosting a web application in your VPC. Now that must be accessible by the people from internet. So that is the route we need to define here. So that if somebody is trying to access your web server, it can be accessible. And for now, nothing is accessible. Everything is private. So whatever we have created, all the places are private by default. Unless we define a route, proper channel to access my resources on the VPC, it will not be accessible. Even you cannot access it. So now let's design the communication channel. Very first thing we'll be creating is the internet gateway. Internet gateway is not chargeable. You can go ahead and create the internet gateway by just giving the name. So I am giving AWS underscore ISO and create. You will get one unique internet gateway ID, and you just don't need to remember this unique ID. You see that this internet gateway is created. Now you can attach this to your VPC. At the time of creating the internet gateway, it has not asked us to select a VPC. It means this is elastic in nature. How it is elastic in nature? I can attach to my VPC, I can detach from that VPC, I can reattach to some other VPC. You can see here this internet gateway is attached to this VPC. I can go ahead and detach from this VPC. Now it is detached, and I can attach the same VPC which I detached to my new VPC. This one. And this property is called elasticity. Got it? So my internet gateway is attached to the VPC. Fine.
One VPC will be attached to one.
Yes. So the relationship is like this. The relationship is one to one. One internet gateway can be attached to only one VPC, and one VPC can have only one internet gateway. So it is one to one relationship. Okay, guys. So the internet gateway is done. Now it's not by just attaching the internet gateway to your VPC, you will not be able to access everything inside your VPC because we also need to define the internal root. Internal root means, considering the example of island, we have defined one gateway where boats and other things will halt, and from there people will land on your island. Now the people should have proper path defined so that they can come to your apartments or building blocks. So that is called internal route. Internal route is meant for the internal communication as well as external communication. To understand what is internal communication and what is external communication. Internal communication is the communication between two resources of the same VPC. It can be in the same subnet, it can be in two different subnets. But if there are two resources in the same VPC and they are communicating with themselves, that is called internal communication. Okay? And if the communication is between the one resource is in your VPC and one resource is outside your VPC, it can be in some other VPC, it can be not on AWS network also. So any party which is outside your VPC, any resource which is outside your VPC, and your resource inside your VPC is communicating with them, it can be the communication initiated by either of them. That type of communication is called external communication. Okay? So the path which is defined, which needs to be defined inside the VPC for the internal communication is defined by default. We do not need to define the internal path for the internal communication. Why? Because it is being defined by default. When we create the VPC, at the time of creating the VPC, by default routes are being defined. Whatever we define the routes, that is mainly for the external parties. Now you may ask me a question that where do we define the routes? How do we define the path? So for that we have a different component here that is called route table. In the route table, we make the entries, and that entry is nothing but a route. So we give an entry like the destination and target. So destination and target, a set of destination and target is nothing but a specific route, and we define this in the route table. So internet gateway is attached to my VPC. One of my instances running inside the VPC. If I want to communicate to my internet that instance, I will need to define a route. Where? In route table. Okay? Yes. So instance can be in only one particular subnet. It cannot be spanned across two different subnets.
So these routes will be subnet to subnet communication.
These routes are not subnet specific. So whenever we define the route, we define in the route table, and whichever subnet is associated with that route table, the route will be applicable to them. So there are different subnets. We have here 3 subnets, and by default we have one route table here. So if you go to the route tables, and if you look at this is the route table for AWS VPC. By default, this route table has been created, and in this route table, you will find only one route, and that is the local route, which we do not define, which we cannot delete, which we cannot modify. So you can see here, this is the route, where the destination is nothing but the complete CIDR of my VPC. and the target is local. So the communication can start from any IP address from this range and it can communicate locally. Fine, this is the meaning of this rule. Got it? And here in the subnet association, you will not find any of the subnets, these three subnets associated with this. Here you can clearly see that you do not have any subnets associated. So this default root table is the main root table. Okay. The default root table which gets created after creating the VPC is called main. And main root table is associated to all the subnets by default, and that association is soft association. Soft association means it will not be populated here. It will not say that this is associated, but these rules will you can see in your subnets. So now if I go to the subnets, and here this is one of the subnets, third subnet. If you go to the root tables, you can see that this is the root table, the main root table, and you will get the root of the main root table. The point here to understand is that if you do not associate your subnet to any of the root tables, the particular subnet will fetch the root of your main root table. हिंदी में अगर किसी सबनेट को मैं किसी रूट टेबल से एसोसिएट नहीं करता हूँ, हार्ड एसोसिएशन नहीं करता हूँ, तो उस पर्टिकुलर सबनेट का जो रूट होगा वो मेन रूट टेबल से पुल किया जाता है. ठीक है, मतलब कोई भी सबनेट बिना रूट का नहीं हो सकता. जितने भी सबनेट हम बनाते हैं उस सबनेट में हमें डिफॉल्ट रूट मिलेगा which is the local, और वो कहां से आता है? मेन रूट टेबल से. ठीक है, क्लियर? अब अगर मैं मेन रूट टेबल में, ये जो मेरा मेन रूट टेबल है, this is my main root table. Now if I make one entry in this root table for internet gateway, so let's make one entry here, add another root, and we will keep this IP address open because we don't know the range of the internet IP range. It can be, the request can come from any IP address and the request can go for any IP address. And here I just need to select the IP address and save. So what we did now, we just added one more root in my main root table, that is for public root. This is the public root because publicly anybody can access or can come through this. If you go back to your subnets here, and what do you find here? Another. The same root which is there in the main root table has been propagated to all the subnets, even if the subnet is not associated hardly. So there is no hard link of the subnet and your root table. So the main takeaway from this is that there will be one main root table which will be created by default. Okay, and any subnet which is getting created in a VPC will have the roots from the main root table, unless the subnet is associated to any specific root table. Yes. Clear? Everybody clear this thing? Okay. So if you check other subnets, again you will find that the two roots are here: the internet root and the local root. So when we talk about the subnets, there are two types of subnets: public subnet and private subnet. The subnet which has only local root is called private subnet, and the subnet which has the internet gateway root is called public subnet. So before adding the root to my main root table, these subnets was what? All the three subnets was private, and if I would have created one more subnet, that subnet would also be private. But now all the subnets are public. And what will happen if I create one more subnet? What will happen if I create one more subnet here? That subnet will also be pulling the roots from the main root table, and in the main root table we already have the public root. So by default, that subnet will also become public. So in exams or in interviews, there is a question that by default the subnet is private or public. Public and private, both the answers are correct, but this is not expected answer. The answer is that it depends on the roots of main root table. What all roots are there in the main root table? Based on that, it will be decided that the default subnet is private or public. Got it? So this is how you need to respond, not just by looking at one scenario. Okay, so by default, anything now we create, any subnet we create in this VPC will be public, right? Now let's say that the requirement is that out of these three subnets, I want two subnet to be public, or let's say that subnet 2 and subnet 3 we want to keep private and subnet 1 public. So the requirement is like this. Okay, I want to keep the first subnet as public, and I want to keep rest of two subnets private. Where can we edit? Okay, wait. Let's understand this conceptually first before getting into the practical. For this requirement, where do we need to make the change? Okay, so root table. We have only one root table here. That is the main root table. What changes you want to make in that root table? Do you want to remove the root? Do you want to remove the root? If you remove the root, all the subnets will become private. But the requirement is that I want my first subnet to be public.
You need to change the NAT gateway and say that to the subnets or
Let's do some brainstorming. Let's clear the concept.
create another.
You create another root table. Sir, your point was something like creating one void NAT gateway?
No.
Okay.
This is the NAT gateway.
Uh-huh.
We need to edit it and attach those public subnets for them. Need to associate for them.
So we cannot add the root to a subnet. Okay. So when we do such brainstorming or discussion, we come up with some more points that needs to be noted down here. If you haven't understood this, then note it down that we cannot add the roots in the subnet. The roots can be added to the root tables only, and we have only one root table. So either we can have the internet root in the root table, or we cannot have. Right? These are the only options we have. So in first option is already ready with me, having the internet root, and all the subnets are now public. But the requirement is that only one subnet should be public, and rest of the two subnets should be private. So how to achieve that?
We define the CIDR of that first one, then make it local.
Where do we want to define the CIDR? In the root table. In the root table, we define the CIDR of destination, from where the traffic will come, or to where the traffic will go. Obviously, that is the only option we have. We need to create one more root table. So one root table will have the public root, and one root table will not have the public root. And then associate the root tables accordingly. So now we have two ways to do this. One, we have already added the root, public root in the main root table, right? Okay, so we have already added the public root to the main root table. Now let's create one more root, and let's keep that root table as private. So going to the root tables and clicking on create root table, I will be giving the name AWS underscore ISO and underscore CST for the custom root table, okay? And then select the specific VPC and create. So now when I am creating another root table in the same VPC, there will be one default root. You can see this default root is the local, right? So what is the difference between the root tables, which is the main root table, and the custom root table here now? The only difference is in the public root. Rest of things are same. So can we see that this is now a private root table? And what is the requirement? We need to make the second subnet and the third subnet as public, private, and first subnet will remain public. Okay. So now let's go ahead and subnet association. Click on edit, and then select the subnets which you want to associate with this root table. And this root table is public root table, sorry, private in nature. So I will be selecting second and third as per the requirement. See. So when we save this and when we revisit to our subnet, by checking the roots of my second and third subnet, let's get confirmed that whether this is private or public. Can you see this? My second subnet is private. Let's verify the third subnet. This is also private, and the first subnet is public. Got it? So this is one way to achieve. Now, using this method or using this approach, what will happen if I add one more subnet? If I create a new subnet in this, what will happen? Will that be a public or private subnet? Public subnet, because that will be driving from the main root table, and in the main root table still we have the public root, right?
Yes.
Isn't it? So the decision of adding the internet gateway root in the main root table or in the custom root table depends on the requirement that the new subnet should be public or private. Make sense? Based on this, we can decide that whether we want to keep the main root table as public or private. So now let's say that I want to restrict, or I want only I have only limited subnets that needs to be public. As per the requirement, here you can see I have only one subnet which is public, and rest of the two subnets are private. So by default, by following the best practices, we want to keep the resources by default resources private, unless we want to make it public. Okay. So now what change we need to do now?
Main root table.
From main root table, we need to remove the internet gateway root and add it to the custom root, and then change the subnet association. Isn't it? So there is a option. There is a shortcut for this. We go to this root tables, and in the root tables, it's fetching the root tables. This is the custom root table, right? Just click on set as main root table. So now your custom root table will become the main root. So you don't need to change or edit the roots of main root table. Okay. Now make it. So let's change the impact on subnet. Subnet 1 is now what?
Private.
Subnet 1 is what? Private. Subnet 3 is what? Private. And subnet 2 is what? Private. So the subnet 1 should be public. Check out that this subnet 1 is associated with the custom root table. So whenever we switch the root tables for the main root table all the subnets get associated with the main root table. So we need to associate the first subnet with my public root table. So just click on edit, and from here you can select the. So you can see there are two options. Why only two options? Because it checks that this subnet is the part of which VPC, and then whatever root tables we have for the VPC, it is populating here. So there are only two root tables for this VPC. So we have one custom, and the next one is X main, which was the main. Now if I select this and save, you can see that public root is available. So these are the two ways to achieve the purpose. Clear? Okay. So now, if we launch one instance in subnet 2 and one instance in subnet 1, then which instance we will be able to connect from here? The instance which we will launch in subnet 1, because that is the public subnet. Okay, so what we will do now, we will launch two instances, one in subnet 1 and one in subnet 2. And then we will see how can we connect to both. Okay? But before doing that, there are two small changes that we need to do at subnet level and at VPC level. And these changes are to get the public DNS and the public IP address. Because unless we make this change, when we go ahead and launch the instance in public subnet, we will not be getting the public IP address. And if we are not getting the public IP address, we will be not able to connect to our instance. So these are the subnet level changes that we will be doing only for the subnets of public subnet. So we have the subnet one as public subnet. Select this, go to subnet action and click on modify auto assign public IP and enable this. Save. So this is the first change at the subnet level. After doing this, we need to make one change at VPC level. Already my VPC is selected. You can see on the screen. Now just we need to go to the action, and from here go to DNS, edit DNS hostname, and from here you enable this. So this will give you the public DNS of your instance. That's it. At VPC level, the basic setup is ready. Now what we have done here, we have reserved a private space on AWS cloud, which we can manage and which is logically isolated. So any resource which we are going to create or launch inside this VPC will be logically separated or logically isolated. And the access to that resource is exclusively my privilege. So it will depend on me that who can access and how they can access my resources inside this VPC. So now, got the purpose of what we have done and why we have done now? Okay, let's go to the EC2 management console, and we will be launching two instances. One instance in private and one instance in public. Click on launch instance, and this instance we are going to launch in private subnet. We'll go with the T2 micro default option. Okay, in the launch configuration here we will make sure that we are selecting the proper VPC, correct VPC, and we are selecting the correct subnet. So selecting AWS ISO VPC, and from here subnet 1 is the public one and rest of the two, subnet 2 and subnet 3, are private. What we need here? Private. So we can go with any subnet 2 or subnet 1. We'll go with subnet 2. Okay, and then we don't need to make any change here. Just go to review and launch, and we will revisit the security group. So anyways, we will be getting the SSH security group. Click on this and just go ahead and launch. So my private instance is getting launched. let's rename this. This is AWS underscore ISO underscore PVT. Okay. By the time it is coming up, let's go ahead and launch one more subnet. Sorry, one more instance. And this instance, we will be selecting the NAT AMI. I will explain you why we are selecting the NAT AMI. Okay. So in the community AMIs, search for NAT and select the very first one. So whichever is the first result, select that one and then go ahead. In the launch configuration here, again select the correct VPC, and in the subnet, we will make sure that we are selecting the subnet 1, that is the public one. Now when we select the public one, the auto assign public IP setting which we made at the subnet label, now you can see that this is enabled, and if you change the subnet, it will be disabled. So for two of our private subnets, auto assigning of the public IP is disabled. So you will not be getting the public IP if you are launching the instance in those subnets. But for all the subnet, for all the instances which is getting launched in public subnet, we want to get a public IP assigned automatically. So you can see this enable. But if you want to, change this, or if there is a requirement that you are launching one instance in public subnet and you don't want the public IP, because you are sure that you are going to use elastic IP, or you are going to use or you are not going to connect from internet to that instance. So you can just go ahead and disable this so that you will not get the public IP. Okay. Now let's click on review and launch, and okay, launch this. Select the same key pair, launch the instance. Rename this to AWS underscore ISO underscore. So now we have the public and private instance coming up. Fine. By the time it is coming up, let's discuss one scenario here. Before that, let me open one PPT so that it will help you to understand clearly. So we have the instances ready. We just need to connect to the instances. So which instance should we connect first? Private or public? Can we connect to the private instance? No. So we will be connecting to our public instance first, and then we will connect to our private instance. So this is the public IP address. Okay, now I will open my terminal. Can you see this? Okay. So let me check my present directory. I am in downloads, and here I'm looking for the key pair. The key pair is AWS UK.pa. So this is my key pair. Okay. So if you're connecting from Linux or Mac, then this is how you can connect to the instance. And there is another approach of connecting from the window one. So we have already discussed. So let me connect to my first instance. I will use the command ssh-i, then the key pair file name, that is aws underscore uk.pm, and then the public IP address, okay, EC2 user at the rate public IP address. Yes, and now you can see I am connected. EC2 at the rate the private IP address. Now I just need to use the command sudo -s so that I can assume the privilege of root. And now it says that the VPC, subnet, and route table all settings are working fine. That's why we are able to connect to our instance in public subnet. Now it's time to connect to our private subnet. Before doing that, we have tested one-way communication. One-way communication means connecting from internet to my public instance. Now let's check that our public instance is able to connect to internet or not. So to do so, you can simply run a command yum update -y. If it is able to download the packages and update the packages, it means your instance is also able to connect to your internet. You can see that it has started downloading the packages. It means both way of communication, internet to my instance and from instance to the internet, is working fine, right? Okay. Now if I want to connect from to my private instance, we are already into the VPC network, right? By logging to my public instance, we are already inside the VPC network, and we know that inside the VPC network, any instance can communicate to any other instance inside the same VPC, right? So ideally, we should be able to connect to our private instance now. So let's check that. What we will need here, public IP address or private IP address? Obviously, public IP address has not been assigned, and public IP address is only used when you are connecting from internet. So through internet, if you are trying to connect, then you will need the public IP address. For internal communication, always the private IP address is used. So we can see here, this is the private IP address. Just by having the private IP address, I will not be able to connect. What we will need more? The key pair. So the private part of key, that is .pem file. The .pem file is on my local system, but it is not on the public instance. So how can we get that? One thing is, we can upload the file on my S3 bucket and I can download it here. Or the second way is that I can go ahead and open the file from here, go to downloads, and in downloads, let me search for this. Let me open this. Okay, cancel. I need to open this in the notepad. I will be opening this in text editor. Okay, click on open, and now I can see the content of my .pem file. I can simply copy this content from here, and I will be creating one file here, vi key, or I can use the same name here, AWS _UK .pem. Okay, hit enter. Now the vi editor is open. Click I, and we go to the insert mode. Now just paste the content here. We will make sure that the content is starting with this begin RSA private key and it is ending with an RSA private key. Once you are done, hit escape, then colon WQ, save exit. Done. So now I can see here I have the .pem file. So now I will be able to communicate or connect to my private instance now. So let's check if it's working or not. I'm sure that in the first try it will not work. I will explain you the reason, but let's try. Let's get the private IP address of my instance. Coming to the terminal, I will use the command ssh -i and then AWS _UK .pem is the file, EC2 user @ the IP address, hit enter, yes, and it is saying that the permission is denied. Why? Because of the public key. So if you look, if you type ls -lrt, you will see that this .pem file is having the read access to others and groups. So if a file is having the read access to others and groups, it means that file is not private. So we need to make this private file as private, then only we can use it as a private key. To do that, we will be using the command chmod and make it 600, give it the 600 privilege. 600 means read and write only to the owner and nothing to the user and group. Underscore uk.pm. And now if I run the same command, now you can see I am connected, right? We are connected to the private instance successfully. So one thing we are clear that the private instance we cannot connect from internet, but we might need the internet access to my private instance to download the packages. There cannot be any server isolated fully. If it is isolated, how can I download the packages? How can I do the updates? So one-way communication to the internet, not from the internet, to the internet is required. Anybody having the tendency? Anybody is missing? No? Okay. There are some repeaters, right? ठीक है, मैं एक बार अटेंडेंस शीट लाके फिर से कंफर्म कर लेता हूँ कौन कौन से रिपीट. Okay. So now requirement is that we need one-way access from your instance to the internet, not from internet to your instance. In that way, your instance will also be the private, will remain private, and will have the internet connectivity also. Are you agree with this fact that we will need one-way communication, isn't it? Because how can we keep our servers isolated? We will need regular updates and packages to be updated. So what will happen if I try to download some update packages from here? Will I get some error? Guys, will I get some error? How many agree? Why? Why? Gateway is there, but there is no route defined for this subnet. So subnet to internet gateway, no route is defined for this subnet. Agree? Everybody agree? Okay. Let's check this. Yum update and then -y. It will try for some time and then it will say timeout error. It is not able to connect. So now if I want to make this thing happen, then I will need a instance. I will need an instance in my public subnet, which will act as a NAT gateway. There comes the requirement or the concept of NAT gateway. NAT gateway means, let me explain you with this PPT. So this is one lab just to set up the basic subnets and VPCs so that you can launch the instance and connect to your instances. Now coming to this one, we have already created the VPC and subnets. and we have the internet gateway, custom route table, main route table attached. We have one instance in public and we have one instance in private, right? So this setup we have already done. We are ready up to here. We have also connected to our public instance. So the traffic came through internet gateway, and then in the route table it checked for the subnets which is associated with the route table, and it was found that this subnet 2, which is the public subnet, is associated with the custom route table. So now it has sent the traffic to this one, and since we were using the public IP of this instance, then it is able to connect to my instance, right? And then the instance is able to respond back to my user. So this functionality is working fine. Now in the second, my user is trying to access this one, but this will not work. Why it will not work? Because in the custom route table, the subnet, this private subnet is not associated. So this option will not work. Okay. Now the requirement is that my EC2 instance wants to communicate to my internet gateway. Why? Because it wants to download the packages. So it went to the main route table, the route table to which it is associated, and now it is trying to connect to the internet gateway, but this will not work. Why this will not work? Because in the main route table, internet gateway route is not there. So now what this instance will do, private instance, what will this do? So now instead of connecting to the internet gateway, your EC2 instance, private EC2 instance, will communicate to your public EC2 instance, which is now not only a instance, it is now a gateway. And now it is converting the public that private IP of your private instance with the public IP of its own public instance IP address, and then communicating to the internet gateway. Okay. Now internet gateway is responding back to this instance. It is already having the private IP of this instance. It is sending the traffic or forwarding the traffic back to the origin instance. So this is how NAT works. Network Address Translator is the full form of NAT, where the public IP address and the private IP address, that address is getting translated, and this translation is being done by NAT instance. So this instance is a NAT instance. Now, to make any instance or to let any instance work as a NAT instance, there are few requirements. What is that? First thing is that the instance should be in the public subnet. The instance which you want to convert, or the instance which you want to behave as a NAT instance, that instance has to be in the public instance, public subnet. Unless that is in public subnet, if that subnet is not able to communicate to internet, how it will help somebody else to communicate to the internet? So first prerequisite is that the instance should be in public subnet. Second is that it should behave as a gateway. And to let any instance behave as a gateway, we need to do a small setup or check in the instance level setting, where we select this public instance which we want to make as a public that NAT gateway. We selected this instance, and now going to the actions, to the networking, not networking, go to instance setting, and from here, okay, it's in networking. In networking, change source destination check. So this thing we need to disable. If we disable this source destination check, now your instance will work as a gateway. Okay. So second prerequisite is this. Third prerequisite is that your instance which you want to make as a NAT instance, on that a NAT application should be installed. The NAT application which will do the translation. So there is a script which is written in the native operating system language, which will convert, or which will do the translation of the IP addresses. So to do the third setup, we don't need to make any change because we have already selected a Linux AMI which has the NAT application pre-installed. That's why we have searched for the NAT in the community AMI. Okay. So third prerequisite is already done. Now, if you go ahead and have your simple Linux AMI instance in the public instance instead of NAT, then this will not work. Because in that case, you will have to run a set of command manually on that server to convert it into NAT. Okay? And the last prerequisite. Last is that the this security group. So the security group which is attached to these two instances are having only SSH rule, right? SSH rule. We need to enable HTTP rule. Okay, we need to enable HTTP rule to both the security groups so that your public is communicating to your private through HTTPS and your private is communicating to your public through HTTPS. Inside the AWS network, whenever there is any HTTP, they have their this SSL certificate on all the servers installed. So they follow the HTTPS by default. Okay. So now what we need to do here? We need to change the security group rule. If I click here, I see that only SSH. If I check the security group of my private instance, in inbound rule, I can see that this is only SSH. So we need to make the change in both two different security groups, or else what I can do, if I go to the security groups here and if I see the VPC, so there is no security group for my VPC. Let me create one security group, and this will be for AWS underscore ISO, and I will select my VPC from here, and in inbound rule I will say HTTPS, this one, and here you can give the range of, you can keep it open also, or you can give the range of your VPC CIDR also. Why? Because all the instances, both the instances, for now, both the instances are inside the same VPC. So the source IP address for the both will be from that range only. So if you give 157.2.0.0/16, this should also work, right? And add HTTP also. So again, use the CIDR of 157.2.0.0/16 and just create this. So now you have a common security group which is allowing HTTP and HTTPS both. Now just go to your instances and add the security group which you created to both the instance. So networking, change the security group, and from here you select this security group. Assign. Likewise, I will do the same thing for my second instance. Select the security group. Done. Okay. So source destination check disabled. Security group setup is done. Now the small setup that needs to be done. But before that, let's check that if it is okay. So it's still working. Okay, now one small setup that we need to do at VPC level. Any guesses what we need to do here? Okay, the traffic will start from where? Subnet 2 or 1? Subnet 1. So the traffic is initiating from the instance in subnet 2. because private instance will request for downloading the package. So now the traffic will be initiating from subnet 2, and if it is initiating from subnet 2 and if it wants to communicate to the instance of your subnet 1, then there has to be a path. There has to be a path from your subnet 2 to your gateway, right? So I will go to this subnet, and this is subnet 2, which is having the instance, and in the root table I don't see any path, because unless there is a path from subnet 2 to the NAT gateway, how the EC2 instance will understand, or how your subnet will understand that where should we direct this request, right? Because it is clear that it will not be able to direct through that internet gateway. Address is not here. So there has to be a route which will route the traffic initiating from your private instance to your public instance. And for that, we will click here, edit. Not okay. So we cannot add or change the route in the subnet. For that, we need to make it in the route table. So select the route table, then go to edit, and here click on add another route. Give 0.0.0.0/0, and here select this. So now you can see that in the list of gateways, your public instance is also listed. It means now your public instance will start behaving as a gateway also. So now I am creating a route. Route is created. Okay. Now if I run a command yum update -y, you can see now it has started downloading the package. It means my private instance is now able to communicate to the internet. Clear? Got this? The session has been recorded, so I will be sharing the video, and you can follow the same steps and do the hands-on.
So Windows has a NAT instance as well?
Windows?
Has a NAT
You can also convert your window as a NAT instance. But there is a separate, commands and set of script that you need to run. So what is the purpose of NAT gateway? We converted one instance, and we make that instance to behave as a NAT gateway. But instead of creating one instance and converting it into a NAT instance and managing, and now the management of the public instance is in mine. If my public instance is down, none of my private instance will be able to communicate to my instance. Internet, right? So there is an option of creating the NAT gateway in the VPC. So there is an option of creating the NAT gateway. So in that case, you don't need to create one server or instance and make it to behave as a NAT instance. AWS does it from themselves. So they manages the instance of the servers which will act as a NAT for you. Okay. In which case we should go for the NAT gateway, and in which case we should go for the NAT instance. When we look for very good bandwidth, where the downloading rate is higher. So in that case, your server which is acting as a gateway should be of high capability. So we go for the NAT gateway. NAT gateway in that case, because then AWS is having a very large pool of servers. So as per your requirement, whatever packages you want to download, they make sure that you are getting the maximum available bandwidth for your private instances. Second benefit is that maintenance is not in my rate. Okay. Any questions so far? Okay, so now let's discuss about the ACL, network ACL. You can see here that by default we have 3 ACLs. So whenever we create any VPC, जब भी हम एक VPC बनाते हैं, एक default ACL बनता है. तो यहाँ पे आप देखो एक default ACL बना है ये. The way we have one default root tables created, default root table created at the time of creating the VPC, one default ACL also gets created. Okay? And if you check the inbound rule, here in inbound rule, there are 2 rules, 100 and star. 100 and star. So 100 is saying that it is allow and star is saying that deny. Okay, I will discuss this point, but let's figure out the difference between ACL and security group. In security group, all the rules are allowed, and in subnet, in subnet ACL, we have allow and deny. So we can deny rule, we can have a deny rule, we can have a allow rule. Now, if there is any overlapping rule means, let's say that there is one rule. I'm adding one more rule here, and this rule is, let's say 101 is the number of this rule, and I'm saying HTTP for port 80, and here I'm giving one IP address 123.2.1.1, okay, /32, because I'm specifying only this specific IP address. So now here you can see that these 2 rules are overlapping this one, right? Because all traffic means HTTP will also be a part of it. 0000 means this IP address will also be a part of this. It means it is overlapping, and both are allowed. So which will get the preference? Obviously both are allowed, it means it will get union, right? But when I change the nature of this, I make it deny, then which will get the preference? Deny or allow? Huh?
Deny will get.
No. Then if it is very simple, that get the deny preference or get the allow preference, then what is the rule of rule number? There is rule number, right? So there must be some significance. So the significance of rule number is that if there is any overlapping rule, then the rule with the minimum number will get the preference. So which is the minimum number? 100. And 100 is saying that all traffic all allowed. It means if the HTTP request is coming from this source, that will also be allowed. Why? Because the lesser number of the rule is allowing that, isn't it? Now if I change the rule number and if I make it 99, then what will happen? This will get the preference. So there will be one request, HTTP request generating from 123.12.1.1 will not be allowed, and rest all HTTP requests will be allowed. Got it?
So in this case, both the rules are applicable.
In this case, both the rules are applicable.
And previous only one.
And in previous also both were applicable, but preference was only for that. We cannot say that these rules are not applicable, these rules are applicable, but practically which is getting the preference?
Here both are getting.
Here both are, so it is kind of intersect. So this is the top edge. This will get the preference. And then if we remove this, so after this will be allowed. Right? That's the kind of intersect. Okay. So got the idea about deny rule and then allow rule number, significance of the rule number. Yes.
What is the meaning of star then?
Star means any number. So if you go ahead and delete these two, If you click on this, and if I delete this, so I don't have any rule defined. It means all traffic and everything is denied. So by default, everything is denied. Okay, unless we specify the rule, by default all the rules are denied.
So in case of this, if I define the same rule with allow, ये तो random number है फिर किसको?
If I define any number, so that will get the preference. So let's say that I'm defining 1, 2, and here I'm selecting HTTP, and here let's say that all HTTP. Okay. So save. So now you will have this 12 number rule, and 12 number rule is saying that allow only HTTP request. So rest of the request will not be allowed. Very simple.
And this network ACL is getting created by default.
This one is the default one. Okay. So any change that you make here, this will be applicable to all the subnets. Likewise, we had discussed for the root table. Now, if you want to have a separate network ACL applicable to only a set of subnets, create one custom ACL and associate. Just like we had the subnet association, here also you have the subnet association. So you can associate that particular subnet with that. Okay. The last point here about this network ACL and security group is, we discussed the security group is stateful, right? जहाँ पे हमने प्रधानमंत्री मोदी जी का एग्जांपल लिया था, right? The network ACL is stateless, so that's the major difference. If there is any question coming up in your interview, and if they are looking for some answers from you, they must be expecting the first answer that ACL is stateless and security group is stateful. Got it? So that's it for today. We'll meet up tomorrow and we'll continue with this VPC.